our speaker. So, good morning and welcome to the Fall 2020 William Issa Speaker event. I'm Tom Wasmer, the chair of the Sustainability Committee at Siena Heights University. The William Issa Endowment was created by Daryl and Kathy Issa. Daryl was a graduate from Siena Heights, graduated in 1976, to memorialize their nephew, William Lewis Chapin Issa, who was passionate about the environment. This endowment allows SHU to invite outstanding speakers in the field of environmental sciences and sustainability. Our speaker for the fall 2020 semester is Dr. Jonathan Foley, who serves as the Executive Director of Project Drawdown, the world's most comprehensive plan to reduce and reverse the impacts of the climate crisis. Before joining Project Drawdown, John led several environmental science and sustainability organizations. He received his PhD from the University of Wisconsin in atmospheric and oceanic sciences and launched the Center for Sustainability and the Global Environment at his alma mater and served as the first Gaylord Nelson Professor of Environmental Studies. John moved on to become the founding director of the Institute on the Environment at the University of Minnesota, where he was the McKnight Presidential Chair of Sustainability. More recently, John served as the Executive Director of the California Academy of Science, the greenest science museum of the planet, before he committed fully to promoting and developing climate solutions as the CEO of Project Drawdown. John's talk is entitled Achieving Drawdown, Solutions for a Climate-Safe Future. Please give a warm welcome to Dr. John Foley.
Well, thank you. Thank you very much, Tom. I really appreciate the opportunity to speak to all of you at the Issa Memorial Lecture. I just wish that we could be doing this all in person. We'd hoped to schedule this back in the spring, but just as the pandemic was starting, but I guess we're all now used to doing these things online. So again, I appreciate the opportunity to speak to all of you, and looks like about 100 of you are online right now. So what I'm going to do is, I guess, give a presentation with some slides and talk for a little while. And then I think we're set up at the end. If you'd like to, you can ask questions in the Q&A box that should be available on your screen later. And we'll try to go through a few of those, and Tom can help moderate those. So why don't we begin this morning then? So as was mentioned, I'm going to be speaking about climate change solutions. And I really want to walk you through some of the opportunities we have to really address one of our biggest problems, that is climate change. But when we talk about the future and some of the challenges we're facing now with the issue of climate change, I think it's useful to step back and look at our past and kind of talk about how did we get here in the first place? How did we arrive at this incredible challenge in human history? Because if we listen to our evolutionary biologist friends, they tell us that our ancient ancestors, which eventually evolved to become Homo sapiens, started walking this planet about 6 million years ago. So something kind of like us has been here for 6 million years, at least. And during all of that time, we did affect the environment, at least right around us, around where we lived, where we ate, where we lived our lives, all those kinds of things. But in the last few decades, our effect went from local environmental changes to global. We suddenly became a global species, basically reshaping an entire planet. And you might ask, like, well, why did that happen? Why did that happen so suddenly in a very long period of time? How did it change so quickly? Well, it changed really starting around the 1950s to 1970s. We saw what you might call kind of an acceleration of the human footprint. Our population grew tremendously starting about the 1950s to 1970s. We shifted from being largely a rural species living in the countryside to now predominantly an urban species for the first time in history. And globalization combined with technology, combined with everything else, massively accelerated our global economic activity. And if you just look at the last 50 years, from like 1970 to today, we saw that the human population itself more than doubled. The economy, adjusting for inflation and all that, grew between 5 and 6-fold. So right there, that's a huge change. Twice as many people doing about 6 times more stuff. And that also resulted in a tripling of global food demand, about a doubling of global water use, and almost a tripling of the use of fossil fuels to power our civilization. Stop and think about this for a second, folks, because what's really astonishing is during the last 50 years, we changed more than all of human history, that 6 million years before us combined. So the last 50 years have changed more than all the other humans and our ancestors lived collectively just in a single lifetime. And because of that, we're now not just changing the local conditions around us, we're changing a planet as a whole. And some of those changes are pretty obvious. We can see massive disruptions to things like our forest. For example, here's a place in the Amazon that was quite remote in the 1970s with just a single dirt road and a little bit of clearing just beginning here in 1975. But if we go back to the same place, even as early as 2003, we see massive clearing of rainforests that were previously completely remote. Most of that is actually growing soybeans, and most of the soybeans are shipped half a world away into China to be used as animal feed for pork production. So globalization combined with increasing wealth and changing diets a whole planet away is causing deforestation in some of the remotest parts of the Amazon. And we see today about a third, roughly, of the world's tropical forest cover has already been lost. That's kind of incredible. We also see our footprint in water all over the world. Here in the United States, we can see it in the Colorado River or the Aguila Aquifer, or in California and other places where we're kind of overusing nature's water supply. But maybe the best example of this, where we've consumed more water than nature gives us, would be the Aral Sea, formerly this large inland sea in Central Asia, one of the largest geographic features on the planet. The Aral Sea is actually fed by 2 rivers to the east over there. You see them in the upper right-hand corner. That's basically the water supply of the Aral Sea coming through Kazakhstan. But the Soviet Union started to dam up those rivers in the 60s and 70s, essentially, and diverted that water and used it to irrigate the deserts of Kazakhstan to grow cotton in the middle of a desert. And this is what happened. The water disappeared, and one of the largest inland lakes or seas on the planet just disappeared. And this pattern of kind of overusing and overtaxing nature's water supply has repeated itself again and again and again on every continent, almost every country on Earth. So we can see that our footprint of humanity is really changing the shape of land and water and other things across a whole planet. But then we get to something that's a little less obvious, because it's really about the sky above us, changing our climate. We know we're doing this. This is really not really in doubt in terms of the basic physics. But so let me just walk you through this a little bit. The general idea, and I'm sure you've heard this before, is that starting a long time ago, but especially in the 19th century, we started to burn fossil fuels, we started to clear forests, we started to do other things that released greenhouse gases into the atmosphere. The Earth's atmosphere has always had some greenhouse gases in them. There are always natural ones like water vapor, a little bit of CO2 and other gases. But we humans were doing things that added to that kind of layer of gas that traps heat in Earth's atmosphere and warms the planet. And so we're making the planet warmer than normal because there's more gases than normal. And those gases started to increase quite measurably starting in the 1880s or so, basically. And today they've risen for CO2 anyway by about 50%. So we're now living in an atmosphere that has 50% more CO2 in it than any time in the past 3 million years or so. This is a really different atmosphere than all kind of human civilization has experienced before. And because of that layer of gas being thicker than normal, the planet has warmed more than normal. And just as expected, the planet has warmed about 1 degree Celsius. Back in the 1970s or so, we might have debated this a little bit, but clearly now it is absolutely very clear that we have warmed the planet, and the planet is now warmer than any recent time in geologic history, at least for several million years. And what's interesting is we actually knew the basic science of this starting back when this curve began in the 1850s. We used to give credit to a scientist named Joseph Tyndall, a British scientist, to be the first to really write about increasing CO2 and climate change. But actually, it was an American woman named Eunice Foote, F-O-O-T-E, who first published this actually a few years before Tyndall. Her paper was published, I believe, in 1854 or 1856. But it was basically showing that increasing CO2 would warm the planet, and she really first described kind of the human greenhouse effect. Unfortunately, as a woman scientist, her work probably wasn't getting the attention it deserved, and it was largely forgotten until recently. But I want to make sure that our history books and our science textbooks remember a remarkable woman of the United States in the 19th century. And let's remember her name again, Eunice Foote. So we know that climate change is happening. We've known the science of this for a long time, and the time for debate about the basics of climate change, I think, has moved on now. And we know that this is an incredible challenge because if the climate changes, it can affect a lot of things we care about, like our water, our food, our forest, our health, our storm surges and things like this along coastlines, the severity of our weather systems. But then that all affects our economy, our security, our very health and well-being. And so this could be an incredible challenge if we don't kind of abate climate change and get it under control. If it just kind of keeps careening out of norm into something we've never seen before, that could pose an incredible challenge to civilization. And none of us, blue states, red states, whatever, are going to be better off. In fact, we're all going to suffer if we let this get out of control. But I want to stop you right here and just stop and say it is not hopeless. For years, we kind of denied that climate change was a big issue, and now seems sometimes we've jumped from denial into doomsday and just think that it's too late to do anything. But that's not true. We can still stop climate change. We can't avoid all of it, but we can avoid the worst of it for sure. And we can always build the future we want. Anybody who tells you what the future is going to be for sure really doesn't know. And they're probably trying to sell you something, because we could always build the future we want. It's not written yet. Tomorrow is still tomorrow, and we can change between today and tomorrow. And we need to address climate change to build a better tomorrow, to build that better future, because a lot of the things we care about, a safe and secure economy, prosperous generations, but also with resilience and equity and justice, things that we should all really care about. All of those really critically depend on a stable environment and on climate change being addressed. So that's what I do at this organization, this place called Project Drawdown that Tom mentioned before, where we're kind of a nonprofit think tank made up of mainly scientists and analysts, but also kind of writers and artists and communicators to be a resource on climate change solutions. We don't worry talking about the problem anymore. We're talking about what we can do about it and how we can move forward. But we use this name Drawdown for a very particular reason, because basically it's about this. This shows now all of the greenhouse gases, CO2 and all the others that humans have started to change, starting back even in the 18th century a little bit, and how they're rising. The higher that curve goes, the warmer the planet gets and the more disruption it's going to cause. So this is what's happened so far. We've risen greenhouse gases up to about that point. And we have a choice to make. We could just keep doing what we're doing now, and that curve would continue to grow, getting worse and worse and worse. Or we can bend the curve, just like we try to do with pandemics, we can try to do with climate change. We can take a curve that's going in a bad direction and bend it through a lot of effort and hard work, and it doesn't happen overnight, just as like we're seeing with COVID-19. But we can eventually bend the curve and begin to address climate change and get it back under control. The moment that we hit that point where we stop rising levels of pollution and start the decline of those levels of pollution, that is the moment of drawdown, when we start to bring back down greenhouse gas levels. So we refer to that moment in time, a period we want to get to. So drawdown is the moment in time in the future when greenhouse gases stop climbing and start to steadily decline. And that's the moment we've managed to stop future climate change. And so that's our mission. We want to help the world get there as quickly, but also as safely and equitably as possible. So how do we do it? How do we achieve drawdown? How do we stop climate change? Well, the problem is, again, basically that we've been adding greenhouse gases to the atmosphere. They're not just carbon dioxide, by the way. There are about 4 major categories of greenhouse gases, and we have long-term historical records for 3 of them. And the 4th is a really kind of new gas to Earth's atmosphere that I'll show you in a second. but we see that they've all been rising together. We have carbon dioxide, we have another gas called methane, or CH4, and then we have a third gas called nitrous oxide, or N2O. And then a fourth gas I'll tell you about later called fluorinated gases, or we sometimes just call F gases. So where do they come from? Well, you've often heard that CO2 comes from burning fossil fuels. We hear a lot about coal and oil and natural gas and how we've got to get away from fossil fuels. Yep, that's true. The warming we will see from the greenhouse gases we emit like this year, about 62% of that warming over the next 100 years or so will come from CO2 released from burning fossil fuels. So if you want to attack about 62% of the climate problem, you talk about fossil fuels and the CO2 that they release. But other things release CO2 as well, not just burning fossil fuels. It turns out cement and some of our industrial chemical processes, just kind of making stuff, especially cement, also releases CO2. Cement chemically, as cement is curing and how we make cement, releases CO2 to the atmosphere, not because we burned oil or gas, but because of the chemistry of cement itself. In fact, if cement were a country, it would probably be the third or fourth largest emitter of CO2 after China and the United States. And then we have CO2 emitted from deforestation. When we burn down trees, we burn down forest and things like that. That's just like burning coal. When you burn a tree or you're burning coal, you're burning carbon either way. Just one happens to be alive and one happens to be fossil dead stuff. But they both form CO2 when they're burned. So deforestation, which is largely happening in Brazil, in Indonesia, and a few places like that, that's a big contributor as well. Then we get to the other gases like methane. Methane comes from agricultural sources, primarily. About 2/3 of our methane emissions come from agriculture, mainly from cattle. And then we have it coming from industry, especially the energy industry, especially hydraulic fracturing or fracking that leaks methane, because methane is also natural gas, by the way, and natural gas pipelines that might have leaks in them. And also when we flare natural gas off of oil rigs. So about 2/3 is coming from agriculture, mainly from cattle and dairy cows, a little bit from rice fields, and the rest mainly from the energy industry itself. Now about the cattle, not to be crude here, but we often hear about how cattle release methane out of the back end of their bodies. Let's just say, actually they don't do that. They burp methane. Methane comes out of the front of the animal. It's because they're digesting things in their 4-chambered stomach using rumen that kind of allow them to eat grass and forage and things that we couldn't eat. And as a process of that weird digestive mechanism, they release methane out of the front end of their animals. So just hope you got that clarified today. Then we have one other gas, nitrous oxide, which you don't hear about in climate change, but you really should because it's more than the emissions of most countries in the world. N2O is formed mainly in agriculture, also a little bit in industry, but most of that comes from overusing fertilizers and manure. When you spread a lot of nitrogen-containing fertilizers and manures on our farm fields, especially when it's cold and wet, and you put on too much that the plants can't even take up later, a lot of that gases off as N2O. A lot of the rest actually, though, flows into our waterways, not as nitrous oxide, but as nitrate, which causes water pollution and actually can disrupt ecosystems in the water, all the way from rivers, all the way down to the Gulf of Mexico, for example. So that nitrous oxide kind of points to how fertilizers and other things need to be thought about. And then finally, we have this group of chemicals called F gases I mentioned previously. Those include hydrofluorocarbons and the old chlorofluorocarbons that we've used as things like refrigerants and propellants and insulators. So they're really handy industrial chemicals, but they happen to be super potent greenhouse gases. Back in the 70s, though, we started to phase out one of those gases, the chlorofluorocarbons, because we found that they harm the ozone layer way up in the upper atmosphere. So we got rid of one part of those chemicals, but we replaced them with another called hydrofluorocarbons. Those don't harm the ozone layer way up high, but they do help contribute to climate change. Right now, that's about 2% of the recent warming is caused by these F gases, but that's poised to grow dramatically as more and more people around the world, by the billions, are about to buy their first air conditioners and refrigerators and things like this. especially in countries with very little regulation on how to dispose of those chemicals at the end of life of an air conditioner, for example. So we've really got to watch that one too. And it's one that we've actually taken a lot of attention to. So that's kind of where the pollution comes from fossil fuels, from industry, from materials, from agriculture, and so on. But that's not the whole story, because we can put stuff in the atmosphere from human activities. And this is kind of a picture showing, and I'll go into more detail about this in a few minutes, but this shows kind of what humans are doing, not by the chemistry of it, but like what economic sectors are releasing greenhouse gases to the atmosphere. So you can see in there like electricity and food and so on and so on. We'll talk more about that in a minute. But nature is here too, and nature actually removes some of these greenhouse gases for us for free. We often forget to talk about that. But about 40% of the greenhouse gases we emit each year are removed that year by forest and by oceans. And thank goodness, because if that hasn't been happening, climate change would be already far worse than it is right now. So this is the basic picture. We put in like about 100 units of fossil fuel junk into the atmosphere, warming the planet. Nature takes out about 41 of those, let's say, and it leaves behind 59 of them that build up every year upon year upon year, accumulating, causing more warming each year. So to achieve drawdown, to actually stop climate change, we have to look at both sides of this equation. On the left is us, our pollution. On the right is nature. We can work with both sides of this equation, if you will, and try to lower the greenhouse gas levels in the atmosphere. For example, we can stop the pollution. We can bring those down to zero. It'd be like, think of this like a bathtub that's overflowing. The atmosphere is the bathtub. On the left is the faucet. We're pouring more water in, and the right is the drain that's taking water out. Right now, we're pouring way more water in than the drain can absorb, so the water's overflowing, causing damage. But let's turn off the faucet, and if we, over the next couple of decades, start to turn down the emissions from energy and agriculture and other things, we can really do a huge job here. And then we can also make sure that the drain keeps working, that is nature, removing greenhouse gases, especially in healthy forests and healthy oceans. And if we do that, then we start to bring down the levels of greenhouse gases again and restore the planet back to a bit more normal state. So that's how we're going to think about this. This is how we're going to walk through all the solutions to climate change that we have at our disposal right now. I'll walk you through some of these. Don't worry about the details. They're all available online. I can point you to that later. But I just want to walk you through some of the basics. So the first thing to do to stop a problem is to stop it at the source. So we want to start by reducing the sources of greenhouse gas pollution and eventually bring them to zero, or as close as we can to zero. And that's that left-hand side of that kind of diagram I showed you before, all those things we do that produce greenhouse gases. So what are those? Well, first, they are making electricity. About a quarter of climate change today is caused by making electricity, using coal and natural gas primarily, burning them in a power plant to make electricity go. Okay, so about a quarter of our problem is electricity. Interestingly, a lot of people don't know this, but about a quarter of climate change, roughly equal to electricity, is coming from food and agriculture and land use. Now, I should mention, by the way, these numbers are for the whole planet. If I just looked at the United States, for example, it'd be a very different mix. Or if I looked at Brazil or India or Japan or wherever. But when you look at the whole atmosphere, this is what it looks like. And the atmosphere doesn't care about national boundaries. We have to do this all together. So electricity and food together are about half of the problem of climate change. Then we have industrial emissions, basically making stuff. We have transportation, moving stuff, cars, planes, trains, and all the rest. We have the emissions that come from buildings themselves, from a building envelope, like from a furnace or hot water heater, a boiler, things like that, versus the electricity they use. So buildings actually have a bigger impact because they use electricity. They're made out of things developed in industry, and they emit stuff directly from the building itself. So buildings turn out to be pretty important. And then everything else, largely from the energy sector alone, from like making petroleum products out of crude oil or natural gas flaring, fracking, all that, is the remaining 10%. But just look at the first 90%. On just one hand, you've got 90% of climate change. You got to think about electricity, You got to think about food, you got to think about making stuff in industry, moving stuff in transportation, and how we use and maintain buildings. So electricity, food, industry, transport, and buildings is 90% of climate change in just 5 places. So we can look at those 5 places and figure out what to do. I already mentioned that producing electricity is a big problem because we're using fossil fuels that burn and produce CO2 going into the atmosphere to do this. So we can change the way we produce electricity, but don't forget we can also change what we use. Maybe we don't have to use so much electricity by being more efficient in our buildings and industry. So we can kind of look at the demand of electricity as well as the supply of the electricity we actually need. So when we look at climate change solutions, we often start with efficiency. That list I won't go through is a list of efficiency solutions that we've looked at around the world and crunched the numbers on to see how effective they could be and what they would cost. These are some of the best, easiest, and cheapest solutions to address climate change, is us being a bit more efficient, especially in buildings and industry. And then we can shift the way we make the electricity we actually need from burning gas and coal to things that don't emit CO2 at all, like solar and wind and so on. Those are really, really important. And a lot of them have gotten cheaper than fossil fuels. Years ago, you might have argued we shouldn't do this because it's kind of expensive. Now it's actually the cheapest way to make a lot of electricity. So when we look at all those solutions put together, we found that a combination of efficiency and shifting the way we make electricity can actually be huge solutions for climate change in that sector. Here I showed all the solutions we've tried to quantify and kind of analyze with crunching the numbers on. Each circle represents one climate solution, and the bigger the circle is, the bigger the impact it can have on climate change. Some of them have 2 circles, like an inner one and an outer one. That represents a range of what we think might be plausible over the next 30 years, depending on what choices we make. So that's the electricity area. There's a lot we can do there. We also have food, of course. I mentioned that food emits about 24% of greenhouse gases. And a lot of people get confused about this, thinking, oh, it's about like organic or local food or GMOs or no, that's like, nope, actually, that's very kind of secondary to the big issues on climate change in food. They're important for other reasons, though. But on climate change, the big issues are deforestation. That is, if we burn down rainforests, let's say in the Amazon, to grow more cattle or more animal feed, or in Indonesia, maybe for palm oil, things like that. So deforestation is the biggest problem. We don't do much of that in the US, by the way, so that area is not so much a concern for us directly, but it is a concern globally, and we consume a lot of stuff made in Indonesia and Brazil. Then we have methane coming largely from animals, our cattle and our dairy cows and stuff like that, and a little bit from rice fields. We have that nitrous oxide, that stuff I mentioned before that comes from overusing fertilizers and manure. And then we have everything else in the food system makes up the remaining 5%. So the big 3 things to think about are deforestation, methane, and fertilizers. Basically, trees, meat, and fertilizer. That's what we have to think about the most. Again, we can start with efficiency. Can we make the current food system maybe more efficient and waste less of it? Yeah, absolutely. Food waste turns out to be one of the biggest ways to do this, because the planet wastes about 30 to 40% of all the food we grow on the planet. That means 30 to 40% of the land and water, fertilizers, and greenhouse gases weren't really necessary to produce the food we need. So we could be more efficient with food waste. That's huge. Another area is shifting a little bit more towards plant-based diets. Because sometimes making meat, especially meat and dairy products, can be very greenhouse gas intensive, depending what we're eating and how it's grown. Sometimes it can be a lot less, but a lot of it is a huge greenhouse gas emitter, and maybe we could dial that down a little bit and maybe substitute more plant-based diets where we can. And that would be a great idea too. Then, because deforestation is so important, we need to protect forest, and especially forest around peatlands, like in Indonesia, where there's carbon above ground in the trees, but also below ground in these kind of peat soils that they sometimes sit on. And so protecting them, making sure we don't burn them down, that would help a lot too. Then we, of course, can change the way we farm, maybe using less fertilizers, being more efficient, and maybe storing more of the biomass in the soil, this kind of thing. That would be very helpful as well. So we find solutions, again, around efficiency of using food better, less waste, less meat, and more plants. protecting ecosystems, and shifting the way we farm can all reduce greenhouse gases from agriculture. I'll go through the rest more quickly because there's a lot of stuff here, but I want to give you a more complete picture though, that is not just solar panels. There's a lot of things we have to think about with climate change. Industry, we have to look at that as well, especially how we make metals like steel, how we make cement, how we make some of our chemicals and also plastics, things like that, and how we manage waste turn out to be pretty important. We've looked at a few of these solutions, a lot more will be needed as well. But looking at cement, maybe making plastics out of like biomaterials instead of petroleum when we can, how we make and use refrigerants because they're so important, those fluorinated gases in air conditioners and freezers and so on, and how we can kind of use waste, not just as something we dump in a landfill, but maybe as a resource again through more recycling, composting, and converting that stuff into energy through different mechanisms. So we've looked at a few of these solutions, but we need quite a few more. So these are just a few of the circles in that diagram, but we've already found quite a few that are interesting. Transportation obviously is a greenhouse gas emitting activity. Burning gasoline, diesel fuel, jet fuel, all that releases CO2 from tailpipes and all that into the atmosphere, 14% altogether. Most of that is from roads. About 10% of that 14 comes from cars and trucks. Flying is about 1.8%. You'll sometimes hear people who don't really understand climate change say that number is more like 10% or 6%. It's actually 1.8. They're trying to add other local effects from like the contrails coming out of a jet engine, sometimes those little water vapor clouds that come out of the back. Those do have a very short-term local warming effect of a couple of hours during the sunshine part of the day, if it's clear out, very locally, but globally it's not really relevant. The long-term effects of that are less than 2%, but still important. Every percent matters. So flying matters, roads matter, all of it matters. And again, we can look at efficiency. Let's take what we have now, burning fossil fuels to get around, but do it more efficiently, like a hybrid car instead of a big gas guzzler, a more efficient truck instead of an old truck and all that, of course. Also, we can shift to maybe alternatives, things that don't need fossil fuels to get around, like walking, bicycling, carpooling a little bit would help, public transit, high-speed rail, telepresence. We all are here today virtue of our computers instead of cars and jet planes. That's kind of nice. And then, of course, can we electrify things like cars and trucks, trains, and so on with electricity, power them with batteries and electric motors, and hopefully using renewable electricity produced in your backyard that can actually power vehicles as well. So all of these things from efficiency to transformation are really important. Finally, we'll talk about buildings. Buildings themselves directly from the buildings right on the site emit about 6% of our greenhouse gas problem. Most of that is residential buildings, about 1/3 is commercial and public buildings. And again, this doesn't count the electricity buildings use because that's counted at the power plant, not at the building. And it doesn't count the materials the buildings are made out of because those are counted in the industrial sector. So you have to kind of see that buildings have a direct footprint and an indirect, larger footprint. That's really important. So that's why buildings matter a lot. Again, efficiency, let's take our old buildings and make them more efficient, like, retrofitting the building envelope with insulation, weather stripping, making them smarter with thermostats, building automation systems that know when people are there and when they need heat and water and all that kind of stuff, and all sorts of things we can do. And then we can shift how buildings are using energy instead of like natural gas and heating oil. Can they use heat from a district energy system or heat pumps that are powered by electricity but can still heat and air condition buildings very efficiently, or solar, hot water, all sorts of things. And again, refrigerants, once again, aren't just produced in industry, they're used and maintained at the building itself. So we'd count them there too, because we're gonna make sure like air conditioners and things are tuned up and not leaking the refrigerants out in our homes and our buildings. And again, we can look at all those solutions there too. So I've walked through, I know a lot here, sorry, but there's 5 different areas. Again, electricity, food, transportation, industry, buildings, all that show us a lot of solutions to climate change that can be really helpful. Then we look at nature itself, because nature again removes some of our greenhouse gases for us, primarily in forest and in the oceans. But they can only do that if we keep them healthy. If we tear down and burn down all the forest, or they get really sick and we clear cut them all or whatever, they can't do that anymore. Or if the oceans get too warm or too polluted or too devastated by our activities, that blue arrow starts to go down too, and we've got to take care of that. So on land, we have to worry about the part of the greenhouse gases removed primarily by photosynthesis, where they accumulate carbon in what scientists call biomass, but the rest of us call trees, and in soils, in the kind of the humus that builds up the organic part of the soil. And again, we can look at things that help protect forests by reducing the pressure on them, starting by making the food system more efficient. If we don't need to grow more food because we waste less of it, let's say, we don't have to clear as much forest. And then we can protect and restore forest and other ecosystems. And this is a neat trick. We can actually change the way we farm on existing farmlands so that they absorb carbon. You'll hear a lot about this soon in what we call regenerative agriculture. Unfortunately, it's been massively overhyped by a few organizations that have a vested interest in this, so be very careful here. But when we crunch the numbers, the scientists who crunch the numbers, like us and other groups, find that regenerative agriculture, things that put soil carbon back to the soil and can rebuild the soil, that could be a few percent of climate change solutions there too, but not 100% like some recent claims have made, nowhere near that. But it could be very helpful. And we can also restore lands that used to be in farms that are, but now massively degraded and kind of beat up or salinized or whatever. Maybe we can bring them back into some kind of livable state. So again, protecting and restoring ecosystems turns out to be important, restoring degraded lands, and then this collective process of like regenerative agriculture or agroforestry, things that kind of bring carbon back to the farm in soils or in trees would be really helpful as well. Oceans also absorb a lot of CO2. They do that with chemistry, they do that by building shells, and they do that with the little plants in the ocean, these 3 different kind of pumps that absorb CO2 into the ocean. We don't really affect that very much right now in a positive way, but we could by restoring coastal wetlands, and mangroves would help a lot, by helping oyster beds and coral reefs remain healthy, for example, and other things we can do in the oceans that could at least maintain these sinks of carbon, but maybe even enhance them. That's very, very exciting. Finally, we might be able to mimic what nature does using machines. Right now, there are some prototypes of machines that do what's called direct air capture, where they kind of pull CO2 out of the air and liquefy it essentially and store it below ground. Or maybe more exciting than that is pull carbon out of the atmosphere and turn it into something we could use, like plastics or jet fuel. Instead of using oil to do that, we can use the oil that got burned and put in the atmosphere, use that carbon instead. But right now, these engineering solutions are really far away from being practical and scalable, probably decades. But who knows? And we need that kind of innovation to see what would happen. But right now, nature is way better at this than we are. So preserving forests and oceans is probably our best bet while the engineers keep working. So that's looking at the pollution that we work with nature. And then I'm going to mention a third area we can also look at that I haven't shown you yet. Is really about things that aren't related to climate change, but are good things to do anyway, that turn out to be climate solutions. That is usually improving society as a whole, especially around equality and equity. There are a lot of things around the world we should do. For example, giving more access to girls and young women to education and healthcare. And when those things happen, again, for human rights reasons, not for climate change, but when women get more access to education and parity in healthcare, remarkable things start to happen. You unleash half of the world's population gets more power to do what they want to do, more choices, more options in their lives. And often when that happens, women will have fewer children, but healthier children, much more likely to survive, which is fantastic, but also a little bit later in life. So it kind of bends the curve on future population growth as well, but voluntarily. Nobody's talking population control, 2 words that should never be used in the same sentence again, but it's more about empowering girls and women to make different choices. And when they do, that can take kind of a bit of the pressure off future emissions, while also growing the economy and growing opportunity for most of the world. We also see this too when we give more parity to indigenous communities and let them kind of manage their own forest and their own ecosystems. Those forests tend to be more productive and more diverse and store more carbon than their neighbor's forest. It's quite interesting. So we're also seeing kind of things that are done primarily from a human rights and equality point of view, sometimes have cascading benefits to climate change too, which is a nice kind of win-win. So when we put it all together, we find that there's no one solution to climate change. Anybody who tells you I have the solution to climate change is full of it. Nobody does, because we've got to do a lot of things at once. And we've looked at hundreds of solutions, but these are the big buckets of them. First, we reduce the primary sources of pollution in electricity, food, industry, transportation, and buildings. A lot of those solutions cluster into efficiency and then flipping to a better system that doesn't emit carbon. Then we work with nature that has these kind of natural carbon sinks in forest, a little bit in the oceans we can do. That will probably grow as we learn and understand more about that. And maybe with engineered machines, but right now that's very small. And then things we do that are aiming at improving society, but also have benefits to climate change, especially around health and education and for women and girls. So all of those circles put together are the solutions to climate change. And inside each one of those, there are dozens of individual tactics. But we find that by pulling all these levers together, we can actually stop climate change. I know this will work in Michigan. This analogy doesn't work in other parts of the world sometimes, but there's no silver bullet here at all, but there is a lot of silver buckshot. That's what we need to use to get to climate solutions. And we put it all together, and this is what can happen. We ran all those solutions through a computer model of how the atmosphere works, its chemistry and its physics and all that. And this is the red curve is if we didn't do anything. If we kind of go up to 2020 where we are now and our best guess about where emissions will go in the future, we're going to keep baking the planet more and more. But we don't have to. We could follow the yellow curve or this green curve, these two different scenarios, and show that, in fact, we can stop climate change as early as the 2040s through the 2050s into the 2060s. Everything between that green and yellow curve are completely doable today with current technology and with current economics. And if we did that, that would stop the warming of our planet. Already, we're about 1 degree warmer than we should be, but we can stop climate change before it gets to about 1.5 to 2 degrees warmer. That's still pretty bad, but more than that could be very, very dangerous, and we can at least avoid the worst of it. So that's great. And already, right now, everything I showed you is an existing technology that pays for itself usually very quickly. We have enough solutions to do the job today. And it's only going to get better as these solutions get cheaper and we develop additional technologies that can be folded in to make it work. I mentioned cost a couple of times because you sometimes hear arguments that would be too expensive to address climate change. That's hogwash. It turns out it's not true. Here's what economists call a cost curve, where we take all the solutions to climate change and stack them up left to right from the cheapest ones to the most expensive ones. And initially, yep, some of them will cost a little bit of money for sure. Sometimes things cost money. But if you run that out over time, so many of these save enormous amounts of money or create new revenues. It turns out for every dollar we invest, we usually make about $5 back as a whole from climate solutions. And it creates hundreds of millions of new jobs, many of which could never be outsourced or turned into AI in a computer. So that's pretty cool. Also, these solutions avoid the worst damages climate change could cause in the future from like more storms, hurricanes, all the rest, which could be tremendously devastating, incalculable damages if we let it get out of control. So this is actually probably the best business opportunity in human history. The only losers here would probably be the oil companies who wield a lot of power. And yes, they employ a lot of people, but overall, this is a very good deal for the economy and should be embraced, I think, by capitalists if they really are looking at it honestly. So what do we have? We have some lessons here. First, it is not too late to stop climate change. Even with what we have in hand right now, we could stop climate change with tools we have today that would actually pay for themselves and more very, very quickly. But what we need to do is get moving now. Don't wait anymore. Yes, more solutions, better technology, cheaper technology would be helpful, but we've kind of wasted the last 30 to 40 years diddling around a bit. And now we have to really step on the gas and use every tool we have, ready or not, do it now and move the needle forward. And to do that, we're going to have to kind of do a lot of changes. We're going to have to change the rules, like policies, laws, taxes, regulations, things like that, that help incentivize this better so that it scales much more dramatically. We're going to have to shift capital out of dying fossil fuel industries into new industries that create new opportunities, new jobs, and new opportunity for investment. We need to help reward businesses that look a little bit beyond just their quarterly earnings to longer term benefits to business and society. We still need better, cheaper, scalable technologies for sure, but don't wait. And yeah, you and I have to do a little bit at home too, so our behaviors could help as well, though it's certainly not on all of us. Our individual kind of behavior change could help and is necessary, but it's not the whole solution at all. And we need to kind of deploy these solutions out over the next couple of decades between now and the 2040s. I would start by doing the cheap things now, right away, like energy efficiency, stopping some of the food waste, helping to combat deforestation. We can do all that right now. We can ask demand really the energy industry stop leaking greenhouse gases into the atmosphere and flaring them out and plug the methane leaks. That's a really big quick win. And also, I wouldn't have said this 5 to 10 years ago, but switching to renewables is now a money-making proposition. It isn't just good for the environment. Communities will save money by switching to solar and wind because they're now the cheapest forms of electricity in the world. This is the total cost of electricity. It's dollars per megawatt hour. And solar and wind are cheaper than any form of gas, certainly cheaper than coal, and way cheaper than anything nuclear can do. So that's pretty good. Let's start building it out a bit more. In the longer term, starting today, but through the 2020s and 2040s, we're going to have to make deep investments in infrastructure, like kind of remodeling every building on Earth, for example, helping farmers change the way they farm across the world, infrastructure for transportation and industry and all that. That'll take time, but that means we have to start today. But it may take 10 to 20 years or so to kind of flip over a lot of these pretty big capital investments. And of course, we do need new technologies, especially in a few areas like making carbon-friendly steels, reimagining plastics, jet fuels made out of pollution, not out of oil. Things like this are all possible, but they're not yet scalable or very economical. So we do need some technologies to drop in along the way. But mainly, we just need to get started because 90% of what we need to do works right now. And so when I think about addressing climate change, I don't see just the problem. I see an incredible opportunity. Because not only do we have to reimagine the world, we get to. This is like the IT and computer revolution times 10. This should be like Bill Gates' biggest dream ever, is to reimagine the world. Every way we use and make electricity, how we build things, how we build our infrastructure, how we get around, how we use and produce food. These are opportunities to make a better world, not just one that's good for the environment, but one that's good for our economy, our security, our communities, our health, for all sorts of things that we need to fix anyway. So this is a great chance to kind of reboot the world from a 19th century powered world of burning coal, basically, and using bad forms of agriculture to a 21st century world that could be more secure, more prosperous, more safe and healthier, and avoid the worst of climate change. But to get there, we need more than just technology, science, and policy and economics. We need, I think, a bolder kind of vision and leadership. Regardless of which way you might vote, I'm personally would say that our leaders lately in the last couple of decades have done a very good job of dividing us and talking about the problems the world has and pointing fingers at the other guy, saying they're the reason why things are so bad. But that's not really the way we should look at things. Martin Luther King didn't go around America saying, I have a nightmare. He talked about a dream. He said, I have a dream of a better world, a world where we bring ourselves together and judge ourselves on character, not the color of our skin, for example. And he invited everyone to join us and join in this incredible dream that he had. He didn't just invite people of color, he invited all of us to be part of that dream. We're nowhere near finishing his dream, and he died for that dream, of course. It's tragic, but we saw a vision of a better world, and it brought us together, or tried to build it. And I would love to see more leadership like this saying we can actually build a better world for our future, for our children, for the next generations. And I don't care which way you vote or where you live, all of us care about our children and everybody believes in a better future. And it wouldn't it be great to have leaders again who reminded us of the best of who we can be and to work together and to achieve that for people who would come after us. And that's the kind of vision and leadership that would really build a better world. And I think that kind of leadership isn't just going to come from places like Washington. In fact, that might be the last place some of them come from some days. But it can come from other places too, from all of our communities around the world. And it come from you. And so that's my ask of you, is to, learn more about these issues, about how things like climate change, but other issues can be an opportunity to build a better world if we work together and saw opportunities for making things better, not worse, and by uniting us instead of dividing us to get there. And I would encourage you to look at the science and look at the numbers yourself and learn more about them and share more about them. I hope we can be a resource. Please, if you like, go to drawdown.org or follow us on Twitter and Facebook and all the rest at Project Drawdown. And all of the numbers and all the kind of sciencey stuff I showed you before are available there for free. And we show you how we got them, and we'll keep them up to date as things change over the next couple of years. And finally, I'd ask you all to remember that the future is not written yet. If you want a better future, go out and build it. Because Robert Anton Wilson likes to say, the future is up for grabs, and it belongs to people who will take the risk and accept the responsibility of consciously creating a future they want. And after all, I think that's the one thing that does unite us, that makes us human, is the desire to leave a better world for our children and the next generations. And that, above all else, should be the defining characteristic of our time. Let's go out there and build that better world and make sure we leave it for people who come after us. So with that, I'd like to stop and say thanks and switch it back to Tom to see if we can actually do some questions and conversation. And look forward to hearing from you all over the next few minutes to see what we can do here.
Fantastic. Thank you very much, John, for a very engaging talk. We have, I think, 5 questions in the Q&A window. The first question by an anonymous attendee is, I know we as individuals can't do much, but what would you suggest we do to help combat climate change?
Yeah, well, I mean, actually, I would counter that hypothesis. I think individuals can do a lot, but it can't just be our own individual behaviors, like light bulbs and cars and that kind of thing. We need to do that too. So if you're talking about our own personal emissions, there are a lot of things we can do that would help save you money as well, which is not a bad thing. So things like retrofitting your homes. If you live in like Michigan, it's a cold place. I live in Minnesota, it's even colder. So next time you do a remodel of your home, make sure that it's well insulated, make sure your furnaces are up to date and efficient, that kind of thing. Maybe don't go rush out and spend a bunch of money unless you have it. But maybe the next time you have a repair to do or some remodeling to do, or you buy a new house, spend the money up front if you can to save money in the long run on energy efficiency. Also, the next time you buy a vehicle, maybe think about ones that are getting much more fuel efficiency, because every time you don't spend money at the gas pump, that's money still in your pockets. And if you like to switch to more hybrid or plug-in hybrid or fully electric cars, we all know that's the future. Those cars are going to be better, not just good for the environment, they're better and cheaper to run. So that's pretty cool too. Also, food waste, throwing less food away. That's an area where we can all chip in a little bit, whether it's at home or at our schools, universities, communities, things like this, kind of making sure that the leftovers go home with people, that you eat those leftovers, or maybe you have less in the first place, and that might be good for waistlines as well as for food waste. So there's a lot of things we can do there. But I think it's also this individual acts of leadership, not just running for office. If you want to do that, great, that's wonderful. Or keeping our public officials accountable locally and in DC. But also through our businesses and communities. There are a lot of things we can do at our places of worship or in our towns, in our cities, the zoning boards and people who decide where the buses go. That's a lot of climate policy. It's not just Congress or the White House. We have a lot of things right in our hometowns about like, hey, am I allowed to put a solar panel on my roof or am I not? Or why isn't there a bus line here instead of having everybody drive? Or when, all these kinds of things. We can be very, very helpful at the local level and personal level. So individual acts of leadership matter a lot. And what we can do at home is good. What we can do outside the home is even better. And let's do it all, especially when it's in your own interest. I really don't think we should have to ask people to be massively sacrificing things to address environmental problems, because we don't have to. It turns out a lot of these environmental solutions are good things to do anyway, and often create jobs and help you save money. So that's a pretty good thing.
Thank you, John. The second question is short. How do animals emit greenhouse gases?
Yeah, well, primarily, All animals respire. That is, when we breathe out CO2, but that's usually kind of a closed loop because it came from plants we ate or animals that ate the plants. And so that's not the problem. What we're talking about is methane when especially cattle and dairy cows eat grass and forage, whatever we feed them, or animal feed like corn and soybeans. They digest them in a stomach where that carbon is processed and turned into, digestible stuff for the animal, but they burp methane out into the atmosphere, and that is not a closed loop. The plants didn't photosynthesize methane, they photosynthesized CO2, and they burp out methane, which is way more powerful molecule for molecule than CO2 is for causing climate change. So it's mainly cows, it's mainly beef cattle, and it's true for those in feedlots or those that graze. They both burp methane, and that's a big problem for climate change. Grazing, though, can, if we do it right, can absorb some of the greenhouse gases by building back up the soil. And that's something people talk about as a way of offsetting some of the emissions that cows release in the first place. But we're better off not doing that at all and just reducing kind of beef consumption if we can, and then farming what we do eat better. By the way, it's not just cattle, sheep and other ruminants also release, and ungulates release methane from their digestive tract. So it's not just the beef, but it's also lamb and things like that as well.
Thank you, John. Next question is, how do we get governments to do not necessarily care about the environment and are more driven by capital and power to change their mindset?
Yeah, well, I mean, I don't like to vilify any political party or, point of view, because, we live in a democracy where all those voices have to matter, and that's fine. We should just duke it out with the best ideas. But what I find funny is that there used to be kind of a false divide presented, like, we could either have a healthy environment or a prosperous economy. It turns out that's a false choice. We find more and more that the 21st century economies are ones that are more efficient, that are based on more appropriate technologies that can address environmental issues while also leapfrogging to a 21st century way of doing things. Electric cars aren't just good for the environment, they're better cars. Very soon, in about a year or two, electric cars will be cheaper to buy than any gas-powered car will be. And they're already way cheaper to operate over their lifetime because you don't have to keep filling them with gas. You don't have to keep changing the oil, and there's very little repairs to do. This is a great thing. Same thing with, a better home would be one that is energy efficient. It's not just cheaper to operate and better for the environment. It's more comfortable and it has better resale value. So a lot of these things we're doing are kind of common sense things like, hey, it's not about just the environment, it's about just being better. And smart businesses get that. Smart investors get that. If you had a choice between, in the 1970s, between investing in typewriter companies or, and Xerox machines or computers, what would you put your money on? Well, hopefully you put it in the computers because you were making a good long-term bet for a better way to do stuff. So I think that's really how to look at it, that I personally think there's really no real competition usually. There will be some. When one technology will phase out and we replace it with another, there is displacement. There are things that are winners and losers. But overall, and we have to take care of people who are hurt by that, of course. But overall, the economy can grow tremendously while we reduce emissions. In fact, in 2000s, the United States peaked our emissions. They were the highest they ever were back in 2007. During the Great Recession starting. But starting in 2008, they went down dramatically. And even though the economy rebounded and grew to be bigger than it's ever been, our emissions keep tracking down. So the US has lowered our emissions since 2008 by about 15%, and the economy has grown tremendously. So that's kind of good. It proves that we can still have a healthy economy while reducing emissions. Now we just have to bend those curves faster and plummet emissions while we still have a healthy economy. We shouldn't have to give up on having good jobs and good ways of life to address the environment. We don't have to. We just have to be a little smarter.
Thank you, John. How consistent is the Green New Deal with Project Drawdown? Is the Green New Deal part of a solution as you see it?
Well, the Green New Deal isn't a solution, it's a policy statement. Policies are not solutions, they're just pieces of paper. if they actually implement a Green New Deal. But even Biden doesn't like the Green New Deal that much. He sees it as being a little too far in one direction. But his climate plan, I think, is actually much more substantial. So the Green New Deal, I think, is kind of dead in Congress, regardless of what the Senate does. Even Democrats don't uniformly support it. But I think it shared a vision of, the idea that we could address big environmental problems and also help address some of our systemic issues around equity and jobs and development, especially some people who've been left behind in the economy for far too long. So I think the Green New Deal helped articulate some visions that are really, really important to the conversation, and that's great. I think Biden's plans are a bit more pragmatic, but very ambitious. He started off as a candidate not really being that ambitious on climate change, but pretty good. And he was kind of, I think, pressured to, because of the Green New Deal and other candidates, really up his game on climate change, and did so very willingly, and I think with a lot of integrity and enthusiasm. And it's now one of their top 4 issues. The pandemic, the economy, racial justice, and climate change are the top pillars of the Biden-Harris transition team that you see right now. And it's really informed by the Green New Deal. So I think that's great, but we have to look beyond the United States, of course. We don't talk about the Green Marshall Plan we should have as well, because the US is about 15% of the world's climate change emissions today and falling, and other parts of the world are still increasing. So it's not just what we have to do at home, it's like, how can American innovation and know-how and technology and business acumen be a way of changing what's going on in India, China, and other places? Because the atmosphere doesn't care which country emits greenhouse gases. The whole planet has to do this together. So I love the Green New Deal's kind of aspirations, but I think we're going to pivot from that particular piece of paper to something that maybe we can get done in Washington. But don't forget that states matter too, and cities matter too, and businesses matter too. We can't just look completely to Washington to solve all our problems. We're bound to be disappointed by that. So we need to kind of help Washington get there, but we need to keep the pressure on cities, states, businesses, and ourselves to chip in everywhere we can. Again, silver buckshot, not silver bullets. And waiting for the UN or Washington to be the savior is maybe not always the best bet. But it's pretty exciting to see what a Green New Deal or other kinds of innovations. And I'd love to see the other side of the aisle. Unfortunately, climate change used to be actually pushed very hard by a lot of Republicans too, especially when it made economic sense. And I'd like to see more solutions that are bipartisan and kind of thinking across the aisle. But we've been seeing a little less of that lately because of just so much rancor in DC. But I think it can, I hope it will get better someday. But in the meantime, cities and states can kind of point the way, and Washington can catch up. And I hope that'll happen. That'll be great.
Thank you, John. How do we incentivize the poverty-stricken people around the world who may not be able to eat healthy or buy new equipment that possibly impact the environment, to see the importance of climate change if they are worried about the day-to-day, as most people around the world are?
Yeah, that's a very, very, very good point. It's very hard to many people in the world, especially the people who are still living under $2 a day in extreme poverty around the world. Things like, just day-to-day security, day-to-day food security, access to water, air quality, health, disease. These are really front and center issues. But again, it turns out some of the things we could do that would address poverty and equity issues and public health and other things, really, these incredibly poverty-stricken parts of the world can also be good climate solutions. Like, for example, leapfrogging old technology. There are many parts of the world where building a new coal power plant doesn't make sense. Can they leapfrog that technology to small distributed solar distribution, which is cheaper anyway, and cleaner and better for the air? Let's do that. But we also have to be mindful of the fact that the poorest people of the world are also going to be hit with the impacts of climate change harder than the rest of us. Like middle-class people in Michigan and Minnesota are going to feel climate change, but very, very poor people in low-lying parts of the tropics are going to feel it 100 times worse than we ever will. And so I think we have to be very mindful of the question you raised about how we alleviate poverty and kind of lift people up, or help them lift themselves up, better yet, while also kind of drawing down emissions. The weird thing is that most of the emissions still come from the richest people in the world. So even if very poor people don't do a lot of the work here, most of it is incumbent upon people like us who are in fact responsible for like 80% of the problem anyway, is less than 20% of the population. So I think, it's the richer people in the world, like the US, Europe, and the rest, China and India now, to really have much more work to do. And the world's kind of most poverty-stricken communities can leapfrog over old technologies as they develop, and we should help them do that. But also, they're not really emitting very much anyway. So I think that's really that's a bit of a red herring if we need to look at it a little differently.
Thank you, John.
Mm-hmm.
What is your opinion on permaculture systems like food forests? Do the land area save the nutrient symbiotic systems in such ideal balance out when compared to singular crop systems and their easy harvestability?
Yeah, that's a great question. As I was trying to show in my presentation there, agriculture today emits a lot of greenhouse gases, again, primarily by clearing new forest lands to grow stuff when maybe we don't have to. Too many animals emitting too much methane, and too much fertilizer being used when we don't have to. Things like permaculture and regenerative agriculture and kind of just smarter ways of doing agriculture that learn from nature, as well as maybe a little bit from technology, depending on how you look at it, can help reduce those emissions. So that's fantastic. Permaculture, for the rest of the folks listening, is kind of a way of working with nature to mimic the natural cycles that a forest would have, for example, of recycling nutrients within the forest, having multiple strata of canopies of plants, like a tree layer and a bush layer and a grassy herb layer and things like this, and kind of closing the loop on nutrients, water, and so on. It's a really great way to farm, though labor intensive. And maybe a bit more expensive in some ways up front, but in the long term, probably better. Regenerative agriculture borrows a lot of the same toolboxes and uses some of those as well. So those can, if done well, reduce the emissions that come from agriculture. And in addition, maybe, at least for a while, to some extent, they can be a carbon sink as well by growing trees on farmland where there weren't any before, or putting more of the carbon back in the soil, where it can build the soil up to be a richer, darker soil filled with humus and organic matter. That also stores carbon. People are very enthusiastic about that, but the one caveat here is that some of the groups that are so enthusiastic about this are doing very sloppy science. The Rodale Institute, for example, who I love those people, but they did a ridiculous study a couple of weeks ago claiming that 100% of our greenhouse gases could be absorbed in organic farms and regenerative agriculture. The real number is probably less than 5%, maybe no more than 10 at best, highest possible limit. And they just ignored the science being done on that. Same thing with Alan Savory's Institute. There's a lot of claims about how big this could be. Dial it way down. It's still very helpful. But again, silver buckshot, there's no silver bullets here. But again, permaculture, regenerative agriculture, I would love to see more of that. And it'd be great if we subsidized that form of agriculture with our farm subsidies, not just the kind of corn and soybean row to row, pray and spray agriculture that we know has big harms to the environment and is subject to a lot of international commodity battles with China and things too. So we need to rethink a lot about how we farm in this country.
Thank you, John. There's one more question. There was actually one that had 2 votes and disappeared. I don't know how that happens. But reinvent, it's more a statement, I think, but it's kind of implies a question. Reinvent utility company to smaller, support self-sufficiency, local energy generation. EI, each building responsible to be self-sufficient for energy needs. Redefine utility to build, maintain these small-scale systems. Delete current nation statewide grid infrastructure. Why not go this direction?
That's a really interesting idea. There's a lot of ideas called like microgrids, for example, where you might build a community. It's having a large. I think what this person's talking about. I'm trying to interpret the question or statement here a little bit, but I hope I get it right. Right now, we have about several large kind of regional grids of electricity production and utilization across America. We don't have a single national grid in the U.S. at all. In fact, there's huge barriers to that right now. So there is no national grid, but there are some that are kind of like across like New England, across the upper Midwest. I forget the names of all of them. There are about 6 major grids in the country right now. That's kind of an interesting thing. So we can kind of borrow electricity from one part of Michigan and send it to another part, or some from Indiana, send it off to Illinois, whatever. That's actually pretty helpful sometimes when some parts of the country need more electricity because of weather changes, and other places might have more electricity to sell. So it's kind of it's a marketplace for electricity. That actually has some advantages to things like renewable energy, where you might have sun and wind in one part of the country that's producing a lot of electricity, but it's cloudy and dark in another, and still winds in another part. So grids actually are helpful. If anything, I would make more bigger grids and national grids that allow electricity to be flowing across the entire country. We've never built one like that. That actually could promote a lot of renewables to be very effective. So in some ways, I'd go the opposite direction to what this person is suggesting. Have kind of bigger national grids would actually allow renewables to be deployed more easily, not have to worry about energy storage so much. But I do like where this question comes in, is at the local level, couldn't we build at least part of our energy needs to be very hyper local, like a subdivision where maybe it has wind and solar panels right at the place where you're building a community, a neighborhood, and have kind of neighborhood grids. Or instead of every single apartment and home having their own individual water heaters and individual furnaces and individual meters and all that, why don't you have what we call district energy systems, where you maybe have one kind of combined heat and hot water and electricity system for a city or a town or a subdivision? That creates incredible efficiencies. And kind of microgrids that are more self-sufficient, kind of produce electricity and heat and power where you use it. That makes sense sometimes. That makes a lot of sense, especially when you're building new development or in dense areas like urban areas. The European cities do this a lot. Some American cities do too. So I guess I would have, I'm probably not answering this in a clear way, but I would emphasize more flexibility. Local energy systems do make sense and create efficiencies and allow you to plop in renewables very quickly. That's great. So the smaller scale things that this person is suggesting make a lot of sense to me. So I like local kind of self-sufficient microgrids are great. But if they can still remain interconnected so that we can, Michigan can buy electricity from Arizona sometimes when it needs it, because, there might be a surplus of sunshine in Arizona, but it's dark in Michigan right now. That'd be good too. So I think just flexible grids that can be smart, that store energy, then can release it again later, things like this are going to be very, very important. Obviously, some people are really concerned that renewables, tend to produce electricity, for example, and when the sun's shining or when it's windy and all that, but not at nighttime. Well, yeah, but you can store electricity. You can store heat and things like this. Batteries are getting cheaper all the time. And with electric cars, we have all these batteries sitting around in a car, and you plug a car in, electricity can go in both directions. So maybe you can buy electricity for your electric car when you need it. But in the middle of the night, when the car is plugged into your garage, maybe the grid can borrow it back and sell it back to the utility when you don't need it in the middle of the night, and then recharge it in the morning when the sun comes up. Don't know. But we're going to need smart grids at local scales, regular scales, and kind of national scales that are much more capable of kind of moving electrons around than we currently have today. But again, electricity is only part of the problem. We still have transportation, we still have heating and all that. As they get more electrified, the grid will become more and more important, but we have to look at emissions everywhere too.
Thank you, John. So this was the last question I have in the Q&A window. I want to ask you, I will actually post the recording. Somebody asked about that, the recording on the sustainability website. I put it in the chat window, so before you go, you want to relate to that. And that will have your slides, but I want to ask you whether you would share your slides with me as well, because they are kind of better visible in the as a PowerPoint or whatever format it is, if people want to look at the graph, or you can maybe tell me where they can find it on Project Drawdown, and I will post that link.
Yeah, I'll send you the link. We have some of those graphs online, and a lot of them come from a report that was published recently at Project Drawdown. Some of the key data slides are on something called the Drawdown Review, which is far better because not only do you get the graph, you get all the explaining material. So I'd much rather people got that so they didn't accidentally get a graph from me or something that may be misinterpreted later because it didn't have the explanation I provided when I said some stuff. So I would encourage people to go to our website and look for some additional resources there. And we're going to be putting a bunch of more online materials at the end of December, including some online courses that we've already developed that will be published by the end of the year. So those of you who are teachers or professors, we hope you can use those in your classes, and they'll include some nice visuals, but also a lot of short video units that you can drop into a class or have as like an additional reading or viewing for classes that you teach maybe in the high school, college, community college level, wherever you like. So we're hoping those can be very helpful as well.
Okay, thank you very much. I will link to the Project Drawdown website again on that page, on the bottom of the page. It's linked already a couple of times, but if we have it in one section altogether, it might be easier for everybody to find. Good, so thank you very much, John Foley, for this very optimistic talk, right? So it's far from over, game over. We really need to get together and work on the future that we would like to have, as you said. Very inspirational. So thank you very much, John. To everybody, thank you for joining this semester's Issa speaker event. And I'm looking forward to see you again in winter when we have the next speaker. Thank you.
Thank you very much. Take care.
Bye-bye, everybody.